Yeah.
us?
Because you're in my class. You're in the head of the other class. Okay. Yeah, by block.
Did you show them our videos?
If you're not here, you're supposed to look it up. Now, last day, we looked at this relationship. We noticed that. William, thank you.
What's your YouTube?
If you add up the squares, the two small squares off of a right triangle, it equals the big one. So you guys all did fantastic on the quiz today. If you can do those calculations on those quizzes, this unit is easy. It's just applying them. So remember, we did showed you the water demo off of YouTube, right? I'll show you that again, right? So this only works if we have a right triangle. Right triangle, we have 90 degrees here, right? The longest side is across from the 90 degrees. That's called the hypotenuse. The other two sides we call legs. Yes, Cashel?
What if it was 89 degrees?
It wouldn't work. It'd be close, but it wouldn't work,
Has to be
right?
90 degrees?
So, has to be 90. And it's called a right angle triangle. So, the way it worked, those things are filled with water. Remember that? Turned it, and then all the water poured in, right?
How does that work?
Right? So they're saying that area off of here plus the area off of here equals this. And this, we noticed that in our calculation. It wasn't a magic relationship or a one-time thing. It happens every single time as long as we had a right angle triangle.
That's
Right?
not real.
So, what this allows us to do is, if we know two sides of the triangle, we can calculate the third one. That's what this allows us to do. Okay? Escape.
McDonald's.
Yeah. All right. So we did a little bit of a calculation last day. We're going to continue it on here.
I'm making one.
All right. So, back side of the page. All right. The first thing I want us to do is label the sides of the triangle. Two sides are called the leg. One side is called the hypotenuse. The hypotenuse is the one that's most important to get right.
The hypotenuse doesn't make sense.
So the hypotenuse, there's three sides here. Is it the 6.5? Is it the 10.2? Is it the x? Which one is the hypotenuse?
The X.
Sorry? Raise your hand. You've got to guess. I heard some people say Xavier. The x. All right. So, being able to identify the hypotenuse is going to help you figure out which formula to use later on. So there's going to be two formulas that you got to work with, right? So that means the other two sides are your legs, your sides, your A's and your B's, all right? Harder. Take out your nose, all right? Right? So we start off with writing out our relationship. A squared plus B squared equals C squared. Right? And I said last day, hey, it doesn't matter if you mix up A and B. They're just the legs, so it doesn't matter which one you call A, which one you call B. You just copy the numbers down. C is your hypotenuse.
Why aren't they the same size?
They're roughly the same size. It's not drawn to scale.
But they're different sizes.
Isn't Mr. Dhaliwal having to draw this, man? I'm not a graphic artist.
Sizes, but the top one that says it's a lower looks bigger.
Eh. That's just Mr. Dhaliwal's drawing, so I gotta help you. All right. Oh, I used whatever I could. So, the legs are sides A and B. All right? And we're trying to figure out our missing side. So this is the quiz we did, right? So we replace the letter with its value. This is the work I want to see from you, right? I want to see that A squared plus B squared equals C squared written down on your page.
A squared
Right?
plus B squared.
That tells me mathematically you know what relationship we have. Next step, you wrote this out. Now calculate it for me. Grab your calculator. What is 10.2 squared? What is 6.5 squared? Then add those two. Find the sum of those two. Right? So, what's wrong? What do you have for 10.2 squared? 104.0?
The answer is 150.
Shh. What's 10.2 squared? What was it again, Cashel?
104.0.
104.0. All right. What's 6.5 squared? 42.25.
The answer is 146.25.
Hands up, Xavier. Right? What is it, Xavier?
146.29.
0.29. All right. So, we did Pythagoras there. Is that the missing side? Chloe's shaking her head and saying no. What do we got to do next?
Square root it.
Square root. So remember, this gave us c squared, not c. This gave us that box off of the hypotenuse. It didn't give us the side. So we got to do the backwards way. You have the area, you want to find the side, you take the square root, show that. So we go square root of 146.29.
Which is 12.09.
12.09. Say we want it to one decimal place. What would the answer be? 12.1. Right? What should our units be?
12.1
Centimeters. We're measured in centimeters. Okay? All right. So, now, we can use this relationship to figure out missing sides of the triangle, but there's also another thing we can use this for. We can use this to check if something is at a right angle, at 90 degrees. All right, so I'll tell you a little story. All right? Because we want things at 90 degrees, but it makes a nice, proper square corner. So I built my home, well, I didn't build it, I hired contractors and stuff like that. And one of my walls in the house was crooked. And I go to the framers, the carpenters, and I go, hey man, this wall isn't right. Everything else in the house is fine except for this one wall. And what he does is he takes out this tiniest little square like this. And he goes, yes it is. And he puts it in the corner, right? And he goes, see, it's only off by a little sliver. I'm like, dude, it's not good enough. Because I'm putting down flooring. Because if I put my flooring against that wall, by the end of that run, I'm gonna be off by a couple of planks. So he goes, no, it's good enough. So I use Pythagoras and I go, hey, let's make a bigger triangle. And I showed him how far off he was. Right? So you can use this to check if something's at 90 degrees. All by pacing. Right? There's some small triangles like 3 feet by 4 feet by 5 feet. Makes a nice right angle triangle. So
did he?
He fixed it.
You should have just told him you were a math teacher.
Oh, yeah. It kind of came out. Okay, so that's what the next question is. Oh, sorry. No, I jumped ahead. We'll talk about that next day. I was thinking that, all right? So here is if a right angle triangle has a leg of 4 centimeters and a leg that's 12 centimeters, what is the hypotenuse? So first off, draw a picture. We're drawing a right angle triangle. Doesn't matter how you draw it.
It's 16.
But let's go like this. So you're going to draw a triangle. You can draw a little square for the right angle. All right? Come on, William.
Oh, we're drawing. You got
go.
art class. Well, you got this.
Why is this art class?
Okay.
Here's a chip.
Next step, William.
W mistake.
We're labeling the diagram. We have 2 sides of information we need to put on here. We've got, where's my highlighter? I've got a 12 and I've got a 4. Where do they go, William? This is for you.
4 is on the bottom, and then 12 is along the side. Or like.
So, wait, hold on. Let me go 4 here.
And the diagonal one is 12.
Diagonal one is 12.
Yeah.
Do people agree with William's decisions?
Nope.
Sure. I don't know what I'm doing.
No, Chloe, what's wrong? Yeah. All right, so in the question, they said these were legs. All right? And you want to find the hypotenuse. The missing side that we don't have the information for is hypotenuse.
Does it
So
matter which number the leg is?
no, remember the A and B. You can mix up those numbers, right?
Right.
All right. So I'm gonna put an X down, or maybe let's put a C down because our formula has A squared plus B squared equals C squared, right? I just want to put C's down. So we have A squared plus B squared equals C squared. All right. We want to find the hypotenuse, what the C is. We plug in the numbers. It doesn't matter if you mix up the A's and B's. I called A that one, B that one. It doesn't matter if you mix it up. You're just adding the two numbers.
It's
So
160.
12 squared. What is that number? 12 times 12.
144.
144. We have 4 squared. 4 times 4?
16.
16. We get
160.
160. Is that how big the other side is?
Sure.
No. David, what are we going to do? Square root it.
12.64.
Right?
12.6.
So remember, this gave us the square off the side. We need to figure out how big the side is. We got to take the square root.
Which is 12.6.
12.6. Thank you. Now, what should the units here be?
12.6 centimeters.
Yeah, not centimeters squared or anything like that, just centimeters. And that's it.